Practice assignment 10, question number 3.
Yes, sir. I was somehow getting the answer to be in microamperes, not in milliamperes.
Practice assignment 10. Just give me a minute. Week 10. Yeah, it is a 500 microampere. Microvolt.
Uh, so in the actual assignment, it's given to be milliamperes.
Milliampere or millivolts?
So milliamperes.
Question number 4 you are talking now?
So question number 3.
Yeah,
Yes, sir.
it is a microampere. Okay, on the portal. Maybe they are using the. Okay, so it is a in microampere. Okay.
Okay. All right. Sir, one more thing. Since you
Mm.
mentioned that week 9 would also be coming in, but as I saw that in week 9, most of the questions, actually all of the questions were data sheet related. So
So
how?
if any question related to the data sheet, so we will provide you the data sheet also. Okay.
Okay. Okay.
Week
All right.
9 to week 11 is the 40%. I am not saying that it is a week 9 content or week 10 content. If it is a week 9 content related to a data sheet, we will provide you the data sheet also. Okay.
Okay. Got it.
Sir, in the mock last question,
Mm-hmm.
the values of R1 and R2 is not given. So,
Yeah,
sir,
value
how
of
will
R1 is 5K and values of R2 is 15K.
okay?
Okay. Solve
Yeah,
using the
then
R1 and R2 value.
yeah, then we will find. In this particular question, we will use the variance formula, sir.
Yeah. Yes. Any other doubts?
Good morning, sir.
Good morning.
Sir, could you please solve Mock's sixth question?
Okay.
Just the first part.
If you remember that this type of question is already given in the week 3 assignment. Okay, similar
Yeah,
to that
yes, sir.
one we are using.
Sir, I
The thing
tried solving, but I couldn't rectify if it's the correct answer which I am getting. So I just
okay.
wanted it to be.
Okay. So basically thing is that, like for example, if we are not considering this thing, okay, here we are using the VDD by 2 and here we are using the minus VDD by 2. Okay. So
Yes,
what
sir.
is the value of Vx? The input voltage Vi that we apply, the same voltage we are getting at this point, Vi. This is using as a RF and R1. Okay. So the formula for Vx is 1 plus Rf by R1 times Vi. Simple. Okay, Vx is that one. Now what should I do? I just use plus VDD by 2 here plus VDD by 2 here. So that VDD by 2 and VDD by 2 becomes a VDD. Okay, and similarly minus VDD by 2 and plus VDD by 2 become grounded. So it is called a single supply operation. Now in the case of single supply operation, what should we do? We are using add a VDD by 2 at a output. We have to add a VDD by 2 to output. Why? Because if we add a VDD by 2 at this point, VDD by 2 at this point, so we have to add a VDD by 2 at the output also. So my output will be balanced. Clear? Any doubt till now?
No, sir.
Okay. Now,
Sir, I had
yeah,
a doubt.
yes.
Sir, then in VI also we will add VDD by 2, right?
Wait a minute, I just do that part.
Okay.
Okay. Now, if we add a VDD by 2 at this VI point and VDD by 2 at this VI point, VDD, like for example, if we add a VDD by 2 here and VDD by 2 here, okay, at this point. So we don't need to add this one. Why? Because of this VDD by 2, we are getting the voltage is VDD by 2 1 plus RF by R1 because of the mm, inverting terminal. Yeah, one more thing is that this is the plus sign and this one is the minus sign. In the last class I explained this one. This is the plus sign and minus sign. Okay, so because of the non-inverting terminal, if I apply the VDD by 2, so the gain is the VDD by 2 1 plus RF by R1, and because of connecting the VDD by 2 at a negative terminal, we are getting the minus VDD by 2 RF by R1. Okay, so this RF by R1 will be cancelled out, so remaining is total is what is remaining is the VDD by 2. So if I add a VDD by 2 at this point and VDD by 2 at this point, so automatically this VDD by 2 term will be added because of this VDD by 2 and this VDD by 2. So we don't need to add this thing. Clear?
No, sir, I didn't get it. Like, why
Okay.
why was it VDD by 2 times 1 plus RF by R1?
Yeah. Like for example, if we are not added a VDD by 2 at a positive and negative terminal, so we have to add a VDD by 2 at the output point for balance. Why? Because we basically boost up our supply signal as well as the output by the VDD by 2. Okay, this
Uh,
thing is okay.
okay.
This thing is okay.
Yes, sir.
Okay. Now, if I connect a VDD by 2 at this point, so because of this VDD by 2, what we are getting at a VX point? This VDD by
Uh,
2, 1 plus RF by R1, because it
sir,
is
won't
connected
it
on a
be?
positive terminal. Because it is connected on a positive terminal.
But won't it be like VI plus VDD by 2?
Yeah, VI is remaining. That particularly part is remaining. I am not changing that one. That is remaining. Only
Oh,
because of VDD by 2 we are getting this point.
yeah, now got it, sir.
Okay, VI part is remaining. We are not changing the VI part. We only add that which signal will be extra as compared to the VI.
Got it.
Okay, and due to the negative terminal, again VI connect the VDD by 2. So what is the, because of this VDD by 2, what we are getting at a VX point? Minus RF by R1 into VDD by 2. Okay,
Yes, sir.
so what is the overall resultant of that one is VDD by 2. Because the RF by R1 is positive and RF by R1 is negative, so these two terms are cancelled out. So remaining is VDD by 2 multiplied by the 1. So only VDD by 2 term is remaining. So if we add a VDD by 2 at this point and VDD by 2 at this point, we don't need to add VDD by 2. Why? Because this VDD by 2 and this VDD by 2 resultant will be automatically giving a factor of VDD by 2 in the output.
Sir, just a small doubt. Like when you mentioned that we would add VDD by 2 to both the terminals, positive and
Yeah,
negative.
yeah.
So does that mean that we are adding an extra voltage VDD by 2 instead of the ground to 10 kilo ohm resistor?
Yeah, exactly. Instead of ground,
Uh,
we connect a VDD by 2 and then VDD by 2 second terminal will be connected to grounded. So like it will be like we are connecting a battery of VDD by 2 here and now it will be grounded. The battery voltage is what? VDD by 2. You can
but
check the
sir,
week
since
3 week 3 content also for that particular prospect.
oh, sir, but since it's not given in here, like in the original op-amp circuit,
Remaining. Yeah, I am just going on that part.
okay.
Okay, I am going on that part. So that is the operation of single supply operation we can do. Okay, so if we connect a VDD by 2 at a positive terminal, VDD by 2 at a negative terminal, VDD by 2 at a supply, so we become converted a single supply operation. So what is we are getting as the output is nothing but is a simple V1 plus RF by R1 into VI. No change in that one. Okay.
Yes, sir.
I think you are familiar with the week 3 content. So in the week 3 content, what we do, we are added a VDD by 2, VDD by 2. Supply voltage will be boosted up by the VDD by 2. So we are getting a same voltage, output voltage 1 plus RF by R1 into the VI. There is no extra particularly voltage will be added. Okay. Now the thing is that this VDD by 2 is not there. Okay, this VDD by 2 is not there. So can I take this particularly terminal as a this particularly point as a that if this VDD signal will be passing through this two resistance, so at this point while we are getting VDD by 2, okay, my input voltage is now at a positive terminal is nothing but VI plus VDD by 2. Okay, my input voltage is nothing but VI plus VDD by 2 now. Why? Because this VDD will be distributed on across a 10 kilo ohm and 10 kilo ohm. So the voltage drop across this resistance is VDD by 2. The voltage drop across this resistor is VDD by 2. So at this point, what we are getting, the input voltage VI plus this voltage is VDD by 2. So both voltage will be add up.
Yes, sir.
Okay.
Yeah, got it, sir.
So now my circuit should be like that. If I apply a VI plus VDD by 2, that is the RC, again the operation amplifier, positive terminal, negative terminal, that is resistance, Vx point. Okay.
Yes, sir.
This resistance, Vx point. Okay. Now, what is the Vx voltage? And this particularly will be level up by the VDD by 2. VDD and grounded. Okay. So my output because of this supply is what? Vi plus VDD by 2 multiply by 1 plus RF by R1.
There is no use of the capacitor, sir.
The capacitor is basically used for the frequency generation. Okay, or you can take that, like for example, if you are considering this one, uh, so you can calculate the voltage because of this Vi at this point.
Yes, sir. It's just a battery
Okay, just
because
a
it's
battery.
infinite capacitance.
Okay, when you are basically giving this particularly voltage, so this your capacitor will be charged as a voltage, and this particularly charges will be applied at a positive terminal of the operation amplifier.
Okay, sir, got it.
Okay, so Vi plus VDD by 2 is the input signal multiplied by the 1 plus RF by R1. Now, because of you boost up only the supply voltage, now this VDD by 2 you are considered as the input supply. So this particularly supply voltage that you boost up VDD by 2, so that creates a effect in output. Again, a VDD by 2 will be added, similar to the first case we are taking. 1 plus RF by R1 into Vi plus VDD by 2. That is overall Vx.
Sir, I didn't understand why did VDD by 2 like an extra add-on came in.
Because if it is a VDD by 2 and VDD by 2 minus VDD by 2, so we are getting Vx is what? Vi plus VDD by 2, 1 plus RF by R1. Now, if we boost our supply voltage by the VDD by 2, so it will be create an impact on this one in boost up the output voltage also, like similar to this case. Similar to this case.
Uh, Sir, but that like since it's not a dual supply, it's just a single supply,
Single
whereby
supply
it's
operation.
whereby it's VDD and the other terminal is grounded. So
Yeah.
we won't be needing analog ground in the first place, right?
Where we require the ground.
Sir, like we add the analog ground VDD by 2 to the negative terminal whenever it's a dual supply operation in order to convert it to a single supply operation.
Yes.
So, but here it's already a single supply operation. So why do we need extra VDD by 2?
I just take here. Like for example, if I compare this signal, like for example, this is the positive, this is the negative. We are taking this Vi. Okay. What is the output voltage? V out. R1 RF. That is the VDD by
One.
2 and minus VDD by 2. What is the
Yeah.
voltage?
Now, sir, it would be the
What is the VI?
VI
What is the voltage? VI.
VI times 1 plus RF by R1 plus VDD by 2.
Why VDD by 2?
So because here it's a dual supply operation, so and we cannot deal in negative values. So that's why we are adding a VDD by 2 in order to cancel the effect of negative value.
Where is the negative value?
So minus VDD by 2.
This one. This is the output voltage when we apply as a dual supply operation. This output voltage is only when we are using the dual supply operation. This is
Yeah.
not the case of the single supply.
Yeah. Yes.
Okay. Don't be confused that this is the output voltage for the single supply, not it is a dual supply operation.
Yes.
Okay. Now, if we add a plus VDD by 2, add this one, add this one. So what is the change in the output voltage?
So it would also increase by VDD by 2, given the fact that R1 is also connected to a analog ground of VDD by 2.
If it is connected with the, we are not connected any particularly point.
Okay.
We are
Yeah,
not
then
connected
also
any
it
point.
would.
It will
Yeah.
be added the VDD by 2.
Yeah.
Okay. Now the second case is that if we use one more battery here, that is the VI VDD by 2, positive, negative terminal, grounded. Now it is a VDD and this is a ground. Here we connect a VDD by 2. What is the output voltage here?
Now it would be VI plus VDD by 2 times RF by R1 plus VDD by
Simple. Simple. VI plus 1 plus RA by R1.
2. Okay. Yeah. Yeah. Yes.
Okay. Because this input voltage we are taking because of this particularly point and this point, these two are cancel out, and this effect will be only when we are considering these two voltages. So automatically this effect will be coming in the output voltage. So we are not adding any external voltage VDD by 2. We are not required any external VDD by 2 voltage. Okay,
Yes.
clear. Now what should I do? If in this circuit, in this particularly circuit, if I use a VI plus VDD by 2, then what is the output voltage?
Uh, so then it would be VI plus VDD by 2 times 1 plus RF by R1 plus VDD by 2.
Okay, now you compare this circuit with your question. VI plus VDD by 2. This is the grounded VDD ground. So what is your VX? VX is this one.
Oh, okay. Yeah, got it.
Now you can calculate the Vx by Vi. Okay. Second is the V naught by Vi. So Vx, and what is the relation between Vx and V naught? Now here you consider the C2 capacitor. Again, it is a create a effect of VDD by 2, but we are not giving the connected with the VDD by 2, so you can consider the C2 effect. So V out is what? Vx divided
Uh,
by RL plus 1 by CS multiplied by the RL. Basically the voltage divider. Okay. The voltage of across 1 kilo ohm is the V naught. And if Vx is the input voltage, so Vx will be drop across the 1 kilo ohm is the Vx into RL upon 1 plus RL plus 1 by CS. Okay. Vx you already calculate. So can you calculate the, but put the value of Vx from here, from the first part here, so you can calculate the V naught upon Vi.
yes.
Okay. Now the second part is that you have to calculate the operating frequency of the circuit. So this is your input circuit. This is your input circuit. Okay. So what you have to do, you have to calculate the RTH, Thevenin equivalent resistance. Okay. First of all, you have to calculate the Thevenin equivalent resistance. Then frequency formula F is equal to 1 upon 2 pi RC. This R is the RTH. Okay, F is already known, 10 kilohertz. Okay, so you put the value of F, you put the value of RTH, you can calculate the C. That is the C is the C1. That C is the C1. Now, in the output side C2, for the C2, you have to use this circuit. You have to use this circuit. Okay, again calculate the RTH. That RTH is nothing but RL, because there is only a single resistance, so RTH is equal to the RL. Now again the formula F is equal to 1 upon 2 pi RC. RTH C2. Okay, so you can calculate the C2 from here. Clear?
Yes.
Any other doubts?
Yes, sir.
Mm-hmm.
Sir, like I was figuring out Vx by Vi
Uh-huh.
yesterday. So I
Mm-hmm.
was getting this equation 3 by 2 times Vd by 2 plus Vi is equals to Vx.
Mm-hmm.
So like in this equation, we are not getting any exact value of Vx by Vi. Like in previous case, V naught by Vi is simply coming 3 by 2. But in this equation, there is a VDD by 2 term which is not getting cancelled.
No issue. No issue.
Okay.
We are not saying that it is a numeric value, na. That's why we are giving this question
Ah,
as a subjective.
got
Okay,
it,
the
got it.
any value you are getting, just put calculate Vx upon Vi. We are not saying that this is the numerical value. If it is a numerical value, we can give this question in the MCQ part.
Sure. Got it.
Okay, yeah. One student is asking that he is a doubt in question number 5 also. So, any doubt in question number 5? It is a simple
Uh,
question like we are using already. That is the Vx, Vy we are using. So, Vi minus Vx upon R1 is equal to Vx minus Vy upon R2. This is the first equation. Second equation is Vx minus Vy upon R2 is equal to Vy minus V naught upon R3 plus Vy upon R4. Okay. Now Vx is 0 because the virtual ground concept. So V1 by R is equal to minus Vy by R. Okay, sorry, we are not considering the Vx as a 0.
yes, sir. It's
Yes, sir. We
like
0.
1000 by S
Mm-hmm.
is the transformation for that.
Yeah. So now if we put as a for this equation, if we are calculate the V positive minus Vx time As is equal to V out. Okay, and V positive is 0 because it is connected with ground. So minus Vx time As is equal to V naught. So Vx is nothing but minus V naught by As. Okay, so we are calculating a Vy here. So Vy is what? This 2 are R. So cancel out. So Vy is equal to 2 times Vx minus V1. From this one, Vx minus Vy upon R is equal to Vy minus V naught by R plus Vy by R4. Now put the Vx value. Sorry, initially put the Vy value. So Vx minus 2Vx plus V1, sorry, Vi by R is equal to 2Vx minus Vi minus V naught by R plus 2Vx minus Vi by R4. So these two R will be cancelled out. So I am taking the R by R4 here. Okay. So it becomes a minus Vx plus Vi is equal to 2Vx minus Vi minus V naught plus 2Vx minus Vi R by R4. Can I use a journal? So it is a minus Vx plus Vi is equal to 2Vx minus Vi minus V naught plus 2Vx minus Vi times R4. If I simplify in the term of Vx, so I am putting the Vi term in the one direction, Vi, this Vi plus Vi, and this Vi is a plus Vi R by R4. Okay, so I'm taking this Vi, and this Vi is equal to Vx, Vi 2Vx, 3Vx plus 2Vx R by R4 minus V naught. Okay, and what is the Vx? V naught by minus V naught by S. So it is a 2Vi plus Vi R by R4 is equal to 3 plus 2R by R4 times minus V naught by AS minus V naught. So I take a V naught from here common and Vi from here. So Vi 2 plus R by R4 is equal to minus V naught 3 plus 2R by R4 times AS 1 by AS plus 1. And V naught upon Vi is what? 2 plus R by R4 upon 3 plus 2R by R4 times 1 by AS plus 1. If I solve it, so 2R4 plus R divided by R4 in the numerator, and the denominator is 3R4 plus 2R by R4 into 1 by AS plus R4. So these R4 and R4 cancel out. Now what is R4? AS is 100 by S. So it is R plus 2 R4 divided by, this is the S by 100.
Sir, AS is 1000 by S.
Okay, 1000 by S. So AS is 1000 by S. So it is a 1 upon, so R4 plus 3 R4 upon 2R into S by 1000. Okay, now compare this one with the given equation. Four upon, so it equal to 4 upon 1 plus 0.007. So I think so. Okay, so you can calculate from that one. Again, if you are taking the, so it is 2 plus R by R4, 1 plus 3 plus 2 R by R4, 0.001 minus. Okay, so it is a 4. So that means R by R4 is 2. So R is equal to 2R4. Okay, and this one is 7. So 3 plus 2R by R4 is equal to 7. That means 2R by R4 is equal to 4. So R by R4 is equal to 2. That means R is equal to 2 R4, or R4 is equal to R by 2. Okay, so either you compare the numerator part or you compare the denominator part. For both cases, the R4 is the R by 2. Okay. Any other doubts?
Yes, sir. Sir, last term's quiz 2's question number 2.
Last term quiz 2, question number 2. Have you tried in the last class? We discussed this one. Have you tried that one?
Sir, which one? Sir, actually, I was not able to attend last class. So,
Okay. So we write two equations for that one. And try to and ask you to solve that one.
no, sir, not this one.
This
Sir,
one?
no, not this. Sir, actual quiz जो था last term का quiz 2.
Okay.
Yeah. That stability of the poles of second something like
Mhm.
two-stage forward amplifier.
Quiz 2 or Antum?
Sir,
Last
quiz
term.
2.
Wait a minute, I just check. Last term quiz 2. Hmm. Yeah, this question.
Yes, sir. The second part.
Okay.
I mean,
Find
the
the
third part.
stability of this two-stage forward amplifier. Okay, so first of all, we have to calculate the transfer function of this one.
Yes, sir.
Okay, and what is the basically transfer function of that one is, if we are saying that this is the V naught. Okay, so what is the relation between V naught and Vi? V2. So V2 times 1 is equal to V naught. Okay, so that means we can say the V naught and V2 both are same. Now what is V2? V2 is the drop across this capacitor. Okay, so first of all, if this current will be flowing from this circuit, so what is the current that is going in this branch and what is the current that is going in this branch? So let's, if I say the current in the IC2 branch is what? GM2 times V1, that is the total current, multiply by the resistance of opposite branch upon total resistance. So total resistance is nothing but series resistance R2 plus 1 by C2S. Okay, so this is the current that is going in this branch. Now if this is the current, if I multiply with the 1 by C2S, so that will be providing me the voltage V2. So in this way we can calculate the voltage V2. Clear?
Yes. Yes, sir.
Now V2 is what? V naught. Okay, and here we are getting the term of V1. Now we can calculate the value of V1. So what is V1? V1 is this voltage. So if I calculate the V1 voltage, so first of all we calculate the current IC1. So what is the IC1?
GM1 R1 upon.
GM1 V1 VI into R1 upon R1 plus 1 by C1S. Okay, and if I multiply this with the 1 by C1S, we are getting the V1 voltage. Okay, now we put this V1 voltage equation in here. So this is V naught is nothing but GM1 GM2 R1 R2 divided by R1 plus 1 by C1S into R2 plus 1 by C2S, like this way. Okay, multiply with VI, because this VI. Okay, so we calculate the V naught upon VI. Okay, now put the value of G1 and G2, R1 R2 and 1 by C1 C2S. So we are getting an equation S square plus alpha S plus beta in this way.
Yes, sir.
Okay, now how we calculate the quality factor?
The determinant of the equation.
Basically, if you compare this with the second order equation, 1 plus S upon
Omega p square.
omega p qp plus S square upon omega p square.
Right.
Okay, so we have to divide this term with the beta. So the term is like anything a naught upon 1 plus alpha upon beta s plus 1 upon beta into s square. So that particularly will be giving you the omega p, and that term will be giving you the omega p qp. Okay, now with this way we can calculate the qp. So this is your second part.
Sir, the stability.
Second b part. Initially you are asking the b part na? Now find the stability of second order systems. Find how we find the stability. So for this particularly part you can basically calculate the poles of the that particularly second order equation. Okay, you can calculate the poles either by basically this is the second order quadratic equation. You can calculate the pole easily. Now apply the concept of signal system, because prerequisite of that particularly course is the signal system. So how we calculate the stability of in S domain?
Poles must lie in left half plane, right?
Yeah, poles must be lying in the left half of the S plane. Okay, so second order quadratic equation, you know, this is your second order quadratic equation. Either you calculate the pole by basically using the b plus minus b square minus 4ac upon 2a. In this way you can calculate the pole of S. Now if poles will be lie in the left half of S plane, so you can say that your system will be stable.
Okay, sir.
Uh,
Got it.
Sir, but since the equation is already positive, and the quadratic equation, whichever will be formed, would also be positive. So having a quadratic equation with a positive, with all the plus signs, or automatically means that it would be negative on the left half of the plane. So we need to calculate the exact values, or is that explanation fine?
No, you have find the stability of the two poles. So you have to identify only the stability, because no need of, if you are sure that your poles will be lie in the left half only, so you can identify. You can basically with this you can, if you can directly mention that if the poles lie in the left side of S plane, so we can say the system is stable.
Okay, so got it.
Okay. The second thing will be possible is that if you know, if we are getting a two poles at the same position, so the possibility that the system will be the marginally stable. Okay,
Got it.
so that's why it is better that you can calculate the poles value and identify that two poles will be lying on the left half of S plane and both poles will be different. If you say that like if this is my S plane and I am getting two poles here. Okay, so if two poles will be lie at the same position, we can say the basically the system is the marginally stable. Okay, we can't say this is a complete stable system.
Got it.
Okay, any other doubts?
Sir, in the previous term and term, can you please solve the second part of your datasheet problem?
Mhm. What is the second part? Okay, and what
It
it
is
is
question
saying,
B.
yeah, what it is saying is Okay, so we have a one is this one and second is this one. Okay. The value yes. How we solve this one? First, yes, any idea how we solve this one?
So part B, right?
Yeah.
So for it, we'll calculate the fastest charging speed using the iSet, and then we'll just
Mhm.
divide it, and we'll just divide it by the 1,000 divided by the fastest current charging speed. That's all.
Okay. Basically, if you see that the formula is given that the I set is equal to K set upon IOT. Okay. So R set is nothing but K set upon IOUT. Okay. Now what is the K set? That is a 540.
540.
540 ampere into ohm. And what is the I out? 1 ampere.
So
1 by 1 amperes. 1 by 10 by 1 amperes, maybe.
No, 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 no. I termination current, that is 1 by 10.
Okay, sir.
Okay. So it is a 540. Okay. And what is the R term? If you see in the formulas here, the formula is mentioned.
These formulas are also given in the question paper, sir.
If data sheet is provided to you, so it is given to you.
Sir, one more thing. Sir, in the question it asks for DQ24045, not for 24040. And so this should be 560 ohm. Means there are two columns are given. Means for 24040 and 4045.
Yeah,
मतलब
yeah, yeah.
for K I said.
4045. Yeah, 24045.
Hmm.
So
So
24045 it is a 560. Correct, correct.
yeah.
Correct. It is a 560. Okay, so it is a 560 ohm. Correct. Okay, now what is the K R term? So
Sir,
it
for
is to
finding R term, we would have to find a percent I term and then we'll be multiplying K term with it.
yeah. So we have a R term is equal to K term multiplied by the percent term. Okay, so the termination current is what? 1 by 10. Okay, and K term is what? 200. So 200 multiplied by 1 by 10, and if I convert into the percentage, so I multiply with the 100%. Okay, so it is a 20 divided multiplied by the 100, that is a 2000. Okay, so that is 2 kilo. So R term is a 2 kilo. Now you have to calculate that you use a 1000 mAh battery. And you have to calculate approximately time.
Yes, sir. We'll be using K iset and the R iset.
So the fast charging current would be divided.
Yeah, exactly. So what is the fast charging current?
Sir, it's given in the question, I guess.
That's going to be okay. Yeah, that is the 1 ampere. So 1000 mAh divided by the 1 ampere. So it is a 1 hour, or we can say the 16 minute. Part B is on this. Okay,
Okay, sir.
so part A is this one. A. These are two part A and one is the part. This is a simple question. You can calculate f is equal to 1 upon 2 pi root of LC. Okay, so both capacitor you can use the F naught and F. Okay, any other doubts?
Hello?
Yes,
Sir, question, end-term question 7 part 2, plotting the graph. Please explain it.
plotting the graph. Okay. So basically, what is the thing is that if we are getting with the C naught, okay, with the C naught, we are getting a frequency is the F naught, and with the C1, we have a frequency of F1. Okay, so two frequencies, two resonating frequencies we are calculating. Okay, at these two frequencies, like for example, if I say that F naught, so at this particularly resonating frequency, how we calculate the resonant frequency? F naught is equal to 1 upon 2 pi root of LC. And in this particularly scenario, at this frequency, what we assume that the omega, basically impedance of the capacitor will be equal to the impedance of the inductor. Okay, ZC is equal to ZL. Clear? Any doubt in that?
No, sir.
Okay. So if these two R will be equal, so overall what is the equivalent? Equivalent is what? R plus J time XL, sorry, ZL or XL minus ZC. Okay. So if these two are equal, so we can say that Z is equal to R. Okay. So at F naught, we are getting a minimum resistance R. That is minimum. Okay, beyond this frequency, above this one we have a effect of this one higher, below this one we have a effect of this one higher, but this one higher. So overall will be the R plus something, R plus every time it is a something, but only the frequency F naught, it is the value of R. That means this is the minimum impedance. Similarly for the F1, we can say that ZC is equal to ZL, so that means Z is equal to nothing but R plus J time ZL minus ZC, or we can say the XL minus XC. Okay, so if these two values will be equal, so we can say this component is 0. So what is the Z? Z is nothing but R. Okay, so if we are changing the frequency at F naught, Z is equal to R. If we increase the frequency or decrease the frequency, we are getting the higher value of Z. Clear? Now if we are calculating the effective impedance, so if we increase the frequency, so this one is the effect. Again we are getting this particular, this type of equivalent resistance, equivalent we are calculating. So this is the F naught, this is the F1. Okay, one frequency we are getting, so we are getting like that one. So this is your equivalent graph. Blue one is your equivalent. Okay, this shows that this is the Z. Okay, what is the Z? It is a ZC. ZC. This is omega. Okay, so we can say ZC is nothing but what is the, it is a 1 over j omega c. If omega is increased, ZC will be reduced. Okay, so lower frequency, the ZC will behave as an infinite resistance, and for the higher frequency, it will behave as a short circuit. Okay, so this is the ZC graph. Now this is the Z out graph. Z out graph. What is the Z out? Z out is what? It is a R plus J time ZL minus ZC. Okay, and if I calculate the magnitude of this one, so Z out magnitude is what? R square plus ZL minus ZC whole square and root of this one. Okay. Now, initially, if ZC is a infinite, so this particular Z out is completely dependent on the ZC. Okay, so it is completely dependent on the ZC. So we can say my ZL will be 0. ZL is approximately 0 because ZL is what? 1 over J omega L. So if omega is lower, so my ZL will be lower. Okay, as the ZC will be decreases, ZL will be increases. Okay, but at this point where one point is arises where we can say it is a equivalent is this one. So this is not a ZL, this is a Z out. Okay, so this is the graph.
Okay, sir. Thank you.
Any other doubts?
Sir, when ZC is infinity, Z out is
Hmm.
0.
Z out or 0? This
Like
is not a Z
it's
out. No, this is not a Z out. This is a effective impedance. Hmm. This one, this Z out is not a 0. Hmm. We are saying the Z out is when ZC is infinite. This is, I think, ZL. This particular red graph is ZL. This one. This one is ZL. This one is ZL. Okay.
Sir, will the paper is lengthy?
Not so much. I think you will cover it 1.5 hour. You will
So would
cover
it be
that
on?
one in around, yeah, if you go with the easily, so you can cover in 1 hour 15 minutes approximately.
So would it be in similar grounds as with the mock?
Somehow, somehow it is similar.
And sir, there will be strictly 5 questions, right?
Yeah, strictly 5 questions.
Okay.
5 questions, and you have to attempt all 5 questions.
Okay, sir.
Sir, I also sent you a doubt on GSpace chat. Could you please check that once
Mm,
later on?
wait a minute, I will just check. Okay, I will check and reply you.
Sure, sure. Thank you.
Okay. Thank you all and all the best.
Thank you, sir.
Thank you so
Thank
much.
you, sir.